There we go. So anyway, completely inelastic, 2 or more masses stick. So that's the visual. The second thing we're going to look at, so first thing is always the visual. The second thing is what happens to the energy. So in this case, well, in the Superman problem we just did where we caught it, what happened with the kinetic energy? We lost kinetic energy, right? So we're going to say kinetic, or maybe more specifically mechanical is not conserved. Now energy, of course, is always conserved, but mechanical not necessarily, right? In that case, like in the Superman, it turned into sound, turned into heat, etc. So if we wanted to compare the initial kinetic and the final kinetic, what should be true? It's not equal. Let's get more specific.
Initial is larger.
Initial is larger, yeah. So we'll say the initial kinetic will be larger, greater than the final kinetic. Okay, or we can say something like there will be kinetic lost. Okay, or change to heat, sound, etc. So that's collision number 1, completely inelastic. Number 2 is going to be partially inelastic. Now most people will phrase it like this, partially inelastic. You'll sometimes see it written as partially elastic, but honestly the partially inelastic is a better way. The key word though is partial. That's the key word. So visually the two objects are not going to stick. They're going to bounce off each other. And it could be more than 2. Most of the ones we're going to do, it's simply going to be 2. But you could have 3 things or more all colliding at the same time. Okay, will not combine. You oftentimes see the verbiage as they bounce off each other. This would be the visual I gave you yesterday. Okay, if you have one moving towards another, and they separate, right? They don't stick, they bounce off each other. Okay, like that. So that would be that visual. Now the mechanical is going to be the same as the completely inelastic. So in other words, mechanical energy is not conserved. And same thing. So kinetic is greater than final. Kinetic initial greater than final. KE is lost again. Okay, so that'd be number 2. We did one like this yesterday. The example I gave you yesterday was partially inelastic. Number 3, you could probably figure out the name of number 3. What's number 3 going to be? Okay, sometimes you'll just hear the words elastic. That's the key word, elastic. So if they say just elastic, that means it's going to be completely elastic. Okay? Now visually, you cannot tell the difference between collision 2 and collision 3. So visually, they will look the same. Okay? So 2 plus objects will bounce. Visually, 2 and 3 will look the same. Okay? So in fact, this collision I'm showing you, you wouldn't necessarily know if it's partially inelastic or completely elastic. So how do you think we're going to figure that out? What's going to be the difference between the two? We're going to look at the energy. Yeah. So if in this case it's not conserved, well, you probably can figure it out. Mechanical energy is conserved. In other words, what can we say is true about the initial kinetic and final kinetic? Equal to each other, right? So KE initial will equal KE final. Okay, what would be the E lost? Zero. Yeah, no energy is going to be lost because, well, it's conserved. It's all still mechanical. Okay, so visually, if you saw two problems and they're bouncing, there's no way you could know if it's partially or completely elastic. You would have to do the math and figure out, okay, is the energy conserved? Is the kinetic equal to the final or not? Okay? Now, if you look at these three, logically speaking, there is a fourth possibility. Okay? If you look at what we just done, what would be the fourth type of collision? Yeah.
It goes without any, nothing stops it.
No, not quite. Yeah. That is not possible either. With a collision, that would not be possible. Yeah.
When a mass goes through.
If a mass went through, that's true. If it went through it, we would probably consider that a partially inelastic type collision. Just using the logic of the two possibilities, right? What would be the fourth? If they stuck together, you can't see that. If they stuck together and what is true? Energy is conserved, right? So if they stuck together and kinetic energy is conserved. Okay? Now, why this is not a fourth collision is because this is impossible. So it is not possible for two objects to stick and for energy to be conserved. If they stick, you will always, always, always lose kinetic energy. Okay, always. All right, that's a common like multiple choice conceptual question. So just understand if they stick, you're going to lose energy for sure. Okay? All right, I do want to go through one fourth type. This isn't really considered a collision. I'm just going to put it under the heading of explosions. Okay, loosely explosions. So in an explosion, two or more objects separate. Okay, two or more objects are going to separate from each other. Okay, so for example, if I take these two carts and I just set them like this, okay, and I put that, they separated. Okay, so that would be considered an explosion type problem where you have your two objects and they're going to split apart. Okay, we did some yesterday. What were the types we did yesterday? The gun. Okay, so the gun, shooting the bullet, that would be considered an explosion type problem. In your homework, you had some where like people were throwing things. Okay, if you're throwing something, I would consider that an explosion type problem where their separation is happening. Okay. What can we say is true about the kinetic energy in this case? Let's go back to this problem. What's the kinetic energy right now? Zero. How about now? Not zero. Okay, so here it's zero, here it's not zero. So what can we say is true about the kinetic energy? Kinetic energy is final is what? Greater than the kinetic initial. Yeah, kinetic final is greater than kinetic. Now how is that possible? Are we somehow creating energy?
There's potential.
Okay, yeah, other forms of energy. Yeah.
It's transferring from chemical, either when it's in the gun or from you, when you hit something, that's from your body thing, from your arm, ball, or whatever.
Yeah, good. And in this case, it wouldn't necessarily be the kinetic from my arm, but what happened, what am I doing right before? Push, yeah, if I just left it like this, nothing happens, right? So we have to, what am I doing when I'm pushing that in? There's spring potential, right? And once we release that spring potential, so it's coming from that. Or in the case of the gun, that would be chemical energy. That's our starting point. and it's releasing it into something else. Okay, or in the case of throwing, that's us, right? Doing work, changing chemical energy. Okay, let's do one problem then.